Okay, we're live, and let's go and check our roadmap. I'm sharing my screen, and we have target 9, and we should return an index, right? So write a function to search target in nums. If target exists, then return its index, otherwise return -1. You must write an algorithm with log time. So it's simple algorithm for binary search, so we just need to write left that will be equal to -1. So I will just write write it equal to nums length. So I would just take two binaries that is out from our array, and then while right minus left is more than 1, then we do some operations. So first we find a mid by right minus left divide by 2 plus left, and then we can check if nums mid is equal to target, then we just return it. Otherwise, if nums mid is greater than target, so for example we are looking for 2, but currently we on 3, then we should move our right pointer to mid. Otherwise we should move our left pointer to mid, and then we left with left and right. So let's imagine that, for example, we have let's imagine that we have some operations that we cannot find. So in this case, left would be equal to -1 and right or right to nums lengths. So we can return and check if left is equal to -1, then we return right, otherwise we return left, or otherwise no, here we don't need to return actually anything. We just need to return -1, I believe. Let's check. Let's log in. Let's run. Submit. Yeah, so we are done. Let's check our submissions. Yes, we have actually the same submission here. So we can mark as done, and let's go to the next one. Okay, so next one is search inserted position. So give inserted array of distinct integers and some target value. Return the index of if the target is found. Return the index if the tree is found. If not, return the index where it would be if it were inserted in order. You must write an algorithm in log time. So for example, here we should put in 1, here we should put in 4. So let's write our algorithm. Nums lengths while r minus l is greater than 1. We calculate our mid, r minus l divided by 2 plus l. If nums m equal to target, then we return m. If nums m is greater than target, then we should move our right to meet, else we move our left to meet. Okay, so here, for example, when we on 2, first we find 3, and we move pointer here to 3. Then we find 1, and we move our left. So when we move our left, we actually always need to return left plus 1. Okay, this one is also done. Let's go to the next one. Okay. Guess number higher or lower. We are playing the guess game. The game is as follows. I pick a number from 1 to n. You have to guess which number I picked. Every time you guess wrong, I will tell you whether number higher or lower than you guess. You call predefined guess, which return 3 possible results. Okay. -1, guess is higher, guess is lower, or your guess is equal. Okay. So we need to return the numbers that we pick. Okay, so let's create our L, because here we can pick n from 1, so it would be 0, and okay, and right, it would be n. Right, n is already case for us. So let's do like while n minus l is greater than 1, and then we calculate our need with n minus l divided by 2 plus l. Then we can check if, we can call our guess function with m and return some result. And we can check if result is equal to 0, then we return m. If result is equal to 1, the guess is lower, so it means that we should move our n to m. Else we move our l to m. Here we return -1. Let's run. Okay, 10 and 6, so let's check. Yeah, I've just checked this because we have here the maximum integer number. So let's verify with this use case. So I have n equal to 10, and then I have 6. So I start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So I have one pointer here and another pointer I have here. So what does it mean? It means that first I actually check the middle. So the middle, in my case, it should be 5. So I check 5, right? And 5, it's not equal to 1. And result for 5 is 0. Because 5, your guess is higher. I think it should be vice versa, L to M. Okay, here I have N1 and pick 1. So here I have 1 and 0. And here I can just return guess L. Submit. Okay, I have 2 and 2. I guess R. So I guess N. Output. Guess L equal to 0, I return L. Otherwise, I return N. Okay, so now it works. Yeah, and it's actually, as we see, it's easy. So let's go to the next one. Square root of x. So we're given not in a non-negative integer x. We have to return the square root of x rounded down to the nearest integer. The return integer should be non-negative. Okay, so for example, do not use. Okay, so for example, we have 4, and we have to write square root of 4, it's 2. And okay, so we should not use power function here. The square root of 8 is 2, and since we round it down, the 2 is returned. Okay. So let's write some examples. I think we can solve it with binary search. So how we can do it? So we start with 0 and till this x, right? So we take some middle element, so it would be 2, and 2 multiplied by 2 would be equal to 4, and 3 multiplied by 3 would be equal to 9. It's square root. Yeah, square root, so it means which value that multiplied 2 times. Okay, then we have 8. And so 8, it would be between 2 and 3, right? So 8 would be between 2 and 3. So we always need to return to here. Yeah, so it always would be a left value. So let's write it like left equal to 0, then while x minus l is greater than 1, we calculate our mid value. So the same as we have it previously. Then we can check if m multiplied by m is greater than x. Okay. If it's greater than x, then we should move our x equal to m, else l equal to m, and then we return l. Okay, yeah, and we have also, of course, base case when it's equal to 1. We should, oh, sorry. It's equal to 1. Yeah, if 0, then we return x, otherwise no. Okay. 3, 3, 2. What if we will have -1? Well, okay, so I need to check somewhere here. So if x multiplied by x is let's have it right x. Here I have right, middle, right. And here, for example, if right multiplied by right is less or equal to x, then I return right, otherwise left. Okay, let's submit. Okay, so why it's stuck? Why it is stuck? Let's submit once again. Okay, so we have one answer here. Okay. m multiplied by m r equal to x yeah, so if r is equal to max integer, then L is rise integer maybe max value. Okay, so let's check submissions. So x it cannot be less than okay. Okay, so here it should be long. And here it should be L. And here, like in each case, if x is equal to 0, then we return 1 or equal to 1. Okay, what else? Maybe start with 0. Yeah, so we see that we have this algorithm, so it's actually the same algorithm, just this long operation should be checked, and that's it. So let's make it as done, and we are done for today. Thank you.